Welcome back, Fresno City College. This is Todd McLeod, and you are in CIT15, week number 4. We're going to go through what you need to do this week, kind of review. Should be kind of becoming familiar to you now, should be becoming a routine to you now. But we're going to look at what you need to do this week, and then we're also going to talk a little bit more about computers, because that's what we do in this class. So let's get started with that. This week, if we look in Canvas, right, we're in week 4, you need to do all of your assignments. Let me just see if I can make this bigger. Hold on. Boom. Not much bigger. Assignments. And so you have all of your assignments through week 4. You should be done with week 1, week 2, week 3. And then this one you have Excel. Excel is awesome, totally useful. You're going to learn some good stuff, particularly in calculating your grade. That's a huge, very important assignment to help you work less and get paid more. So you'll be able to get better grades in all of your classes and use your time more efficiently after you take this assignment. And then in my IT lab, if we go to course materials, I'll take a look at that. As soon as it comes up, my IT lab is a little bit not so great, but I curve my IT lab grade. So sometimes you'll hit things in here that don't work, like a question doesn't work, just skip it. And I account for that in the grading. So I give everybody a pretty generous curve because my IT lab is a little glitchy. So you should already be done with Windows 10. And I don't care if you do the simulation training. All I care about is exam. You should be done with the exam. That was week 1. And then week 2, we moved into Word. And inside Word, you should be done. That should have been week 2. This should have been week 3. And then week 4, you should be doing chapter 3, or Word chapter 3 simulation exam. So get that one done this week. And the next deal is the exams down here. So with the exams, you should do chapter quizzes, and you should be through chapter quiz, chapter 4. So get through that one. And then the last thing I forgot to mention here in Canvas is you need to do the discussion. Let's see what that is. I'm going to hold down Control and hit plus. There we go. Now we're zooming in. And so you should do week 4 discussion. Watch the movie Disconnect, and then comment on this discussion here. There should be a prompt in there after watching the movie. Right? And you could, that's watch the movie Disconnect. Here's what you can watch. And also in it, how does the movie change the way you view technology? How does the movie change the way you view technology? So go ahead and comment on that. That's what you're going to do. So that's week 4. Okay? Pretty easy. Now we're going to jump into talking about material. And chapter 4 in the textbook and what I talk about in week 4, they align really nicely. So here in chapter 4 of the textbook, you can pause the video. We're going to talk about software, and then we're also going to see that there. But first, we're going to do a little bit of a review. And so we've learned about the purpose of computers, and the purpose of computers is to take data and turn it into information. And then the 4 functions of a computer are input, process, output, storage, right? And then the ontological structure, the ontology of computers, is we take computers and break them up into hardware and software, and then we take hardware and we break it up into input hardware, processing hardware, output hardware, and storage hardware, right? So IPOS, we break hardware up into IPOS. Is it an input device? Is it an output device? Is it a storage device? Is it a processing device like the CPU? And then software, we take software over here. So we take computers, break it up into hardware and software, and we take software and we break it up into application software and system software, which is kind of what we're talking about this week. And then we look at system software. We break system software up into your operating system, your utilities, and your drivers. And sometimes people include translators in there. We're just going to include operating systems, utilities, and drivers. And I misspelled utilities. Look at that. And I'm just going to get rid of that one. Okay, we'll just do that. Ooh, no, I just want the line. Just give me the line. Can you just get rid of the line? Perfect. So that's how we could break up system software. And then application software, we could break that up into many different ways. So that's the ontological structure of computers. And then we also looked at how computers work. And so computers run on electricity. Electricity has two discrete states, on and off. And we could create coding schemes to associate an on-off state with some meaning. And so your porch light on Halloween is a good example of that. If the light's on, it means one thing. If it's off, it means something else. If you have two porch lights, you could store and convey 4 messages. 3 porch lights, 8 messages, 2 to the power of n, where n is the number of porch lights you have or the number of circuits or switches that you have. A switch is anything that's on or off. We then have coding schemes that we could associate with that. So that's kind of how computers work. We could store letters of the alphabet. We could store sounds. We could store colors based upon stuff. Along those lines, we learned about monitors. And with monitors, they have an aspect ratio. Is it a square? Is it more of a letterbox, envelope, kind of structure? So that's the aspect ratio. And then we found out that monitors have a whole bunch of small little lights, and they're called picture elements or pixels. And so HD resolution, 1920 by 1080, means that there's 1,920 pixels going across and 1,080 rows of them, right? And then 4K is 2 times 1920 and 2 times 1080, so 3840 or 2160. And so that's what makes up a monitor, is all those pixels, and each pixel has color depth. And the color depth is how many bits are being used to store the color information for that one pixel, right? And if the color depth is 1, then that one pixel could be one of 2 possible colors. We could be storing the color black or the color green for that pixel, and we store the color information for every pixel. Now there are compression algorithms, right, which can look at a picture and they could figure out some way of storing that color information without having to store the data for every single pixel. So for instance, if we looked at the German flag, right, and here's the German flag, we might come up with an algorithm that says, from this location on a graph, on a chart, to this XY coordinate on a graph, the color is yellow. And from this coordinate to this coordinate on a graph, the color is red. And from this coordinate to that coordinate, the color is black. So we had some formula to store the color information instead of storing the color information for every pixel, which is a lot of data. If we had 1920 by 1080, and we are storing, full color, color depth of 24 bits for each pixel, we'd be storing 49 million pixels, almost 50 million pixels for every single, or 50 million bits for every single, for each pixel, we'd be storing 24 bits. And for all of the pixels, 1920 by 1080 by 24, for all of the pixels to store the color data, for all the pixels, we'd be storing 49, almost 50 million bits, 50 million on-off states, right? Zeros and ones. And but we might instead come up with an algorithm that says, from this coordinate to that coordinate, it's yellow. From this coordinate. And so then a computer that knew how to read that algorithm could then recreate the image for us. And we might call that algorithm like GIF, that compression algorithm or decompression algorithm. It could be GIF or JPEG or PNG. It's a way to compress the data and decompress that data. So it's called a codec. And that's a compression, decompression, right, algorithm. And you can see the compression, right, compression, decompression, right, comes up with the word codec. So we use some codec so we don't have to store all the data information for every pixel. We don't have to store every single bit. Does that make sense? Rewind it and watch it again if that went a little bit fast. And so we learned about monitors, and we learned about pixels and resolution and aspect ratio and color depth. It's pretty good stuff to know about monitors. And then we also learned about computer remembering. And so different places in a computer stuff is remembered. And so inside the CPU, we have registers and we have cache, right, where it can remember stuff. Then there's also random access memory, and this is all on the motherboard. And random access memory is primary storage, and all of those are also volatile, meaning the power goes off and whatever's in there is no longer remembered, it's forgotten. And then we have secondary storage, which is non-volatile. So when the power goes off, whatever's stored there is remembered. And secondary storage is magnetic, optical, and solid state. So magnetic is like a hard disk drive, optical CD, DVD, and solid state would be like a solid state drive or a flash drive. And then there's also ROM, and on ROM, read-only memory, we store BIOS. And that's basic input-output system to get the computer up and running. And so it's a little bit about computer remembering. And that kind of brings us up to speed with where we're at now. So we're going to jump in to the new material in the next video. I like breaking these up because if OBS crashes, I lose whatever I've already said, and it's too late for me to start again. I realized when I was doing the typing, you weren't seeing that. I only had it on full screen, so that's okay. It was just a little bit where I typed it out. Okay, see you in the next video where we will charge forward into new territory.